Don't forget to subscribe and ring that bell.
Hey, 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 welcome back, or welcome if this is your first time. We are going to cover some AP Calculus AB exam questions, and let's do something a little bit more recent, 2022, the free response questions. We are going to start with free response question 1. We get a graphing calculator, thank goodness, and if you happen to be in the market for a decent graphing calculator, I highly suggest the TI-84 Plus CE Color Edition. Man, it's sweet, and they come with a whole slew of colors, not just that boring yellow that your school probably has. Links are in the description below, and I personally have one. I have the mint green one. Oh, I love it. But enough about graphing calculators. Let's start. Free response question 1. Problem number 1 reads, from 5 a.m. to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by A of t, which equals 450 times the square root of the sine of 0.62t, where t is the number of hours after 5 a.m., and A of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m., so no vehicles waiting in line. Okay, the first thing that jumps out to me, whether it's relevant right now or not, is that A of t is vehicles per hour. That means we already have a rate. Okay, A of t is a rate given to us. It's not calculating a quantity, it is rather calculating a rate. Okay, so that jumps out to me. 1A asks us to write, but do not evaluate. Oh, God, I love those because they're so easy. So write but do not evaluate an integral expression. Okay, so I'm going to write something that goes like this. I already know what I got to do. That gives the total number of vehicles that arrives at the toll plaza from 6 a.m., where t equals 1, to 10 a.m., where t equals 5. My God, not only did they tell me it needs to be an integral, they gave me the bound. All right, now, if you haven't figured it out yet, we are going to integrate this. I had mentioned earlier that A of t is a rate. So if I have a rate, in this case, it's vehicles per hour, and I take the derivative of that, that will give me vehicles per hour squared. But if I go backward and I integrate, which is what we're doing, that gives me just the vehicles. That gives me my quantity, not a rate anymore. I was just speaking of that. So we are going to integrate A of t, which is our rate, in order to get the quantity of what? Total number of vehicles. Quantity would just refer to vehicles. All right? So if I want, I suppose I could do A of t dt here. Or, because they give us the equation, why don't we just integrate from 1 to 5, 450 times the square root of the sine of 0.62t. And don't forget, you absolutely need to put dt or you will get points taken off. Okay, so that was a very easy one to start with. I would like to point out something that I questioned myself. Notice that it says total number. That's like, I want to add everything together, so I should kind of consider everything positive, right? Like, shouldn't I put absolute value bars here? Okay, you see what I did here with these absolute value bars? I could do that, and it would absolutely be correct. But let's take a look at our problem up here in the top left. Okay, let's take a look at our A of t function. 450 is a positive number. If I take the square root of something, I will also get a positive number. So A of t is positive with or without the absolute value bars. So most of you probably would have not written the absolute value bars, and it would have still been correct. 1B, find the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza from 6 a.m., where time is 1, to 10 a.m., where time is 5. All right, what do we have to know? Well, the average value, that happens when I integrate something with bounds. Okay, but then I multiply it times 1 over the difference of those bounds. All right, well, I have bounds here, okay, from 1 to 5, which means I need to multiply by 1 over 5 minus 1, the difference. Okay, well, what am I trying to find the average value of? The rate in vehicles per hour. A of t is the rate in vehicles per hour. Okay, so really this is just A of t dt. I can write that on the paper as such because I need a number, and this tells them how I'm getting that number. So in my calculator, I'm going to start off with a fraction, 1 over 5 minus 1. Yep, I don't know why we're here. Second quit. Let's go to alpha, y equals. The alpha must not have registered. 8 times math 9 from 1 to 5 of 450 times the square root of the sine of 0.62. We're using x instead of t. And throw our x here. So this is A of t. Okay, so that's what I have written on my paper. Well, actually, the dt is right here. All right, so I mean, I'm just going to hit enter and get my answer. And if I did that right, it's still thinking 350 or 375.537. I'm going to go 3 decimal places because any multiple choice problem we have always goes 3 decimal places. If you are to round 2 decimal places or 1 or even to a whole number, in this case, because they're asking for the average value of vehicles, I guess 376 would be accurate. As long as you round correctly, they can accept that. But I never leave it up to chance. I always go 3 decimal places because that is what the test always goes to. All right, unless they tell you otherwise, I tell my students 3 decimal places. And of course, vehicles per hour, right? Because it's the average value of the rate. Wow. That's a lot, but we don't even need that. So, I mean, that just seems like it's weird to write 375 vehicles per hour. That seems like a lot of vehicles. So I'm just going to erase that. All right. Actually, maybe it would be vehicles because we're integrating the rate. 1C. Is the rate at which vehicles arrive at the toll plaza at 6 a.m., so right at time 1, is your rate increasing or decreasing? All right. So they're asking us, is our rate, which is A of t, okay, is that increasing or is it decreasing? Okay, increasing and decreasing tells me derivative. So I need to look at the derivative at 1. If it's positive, it's increasing. Okay? If it's negative, it's decreasing. This is very, very simple. We're getting lucky so far. A prime of 1. And again, we have a calculator. So I'm going to go right to my calculator. And I'm going to go to math 8 this time. I'm going to use my x variable. I'm going to put the function in that I want to integrate. 450 to square root of the sine of 0.62x when x is 1. That's 148.947. All right, so let's go here. That's 148.947. Now, they didn't ask me what the rate was. They're asking me, is it increasing or decreasing? So I better answer that question. And then it says, give a reason for your answer. I'll write a little blurb up. Doesn't have to be long at all. So my answer is, it is increasing Okay, now my reason. Since a prime of 1 is greater than 0. That's my reason. A prime of 1 is a positive value. You can write it several different ways. So A, B, and C were pretty simple. Oh boy, that means D might be a little bit of work, but we got this. Oh man. 1D. A line forms whenever A of t is greater than or equal to 400. Okay? The number of vehicles in line at time t for the values between A and 4 inclusive for time is given by n of t, which equals the integral from t to a of a of x minus 400 dx, where a is the time when the line first begins to form. All right. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval from A to 4. Justify your answer. Wow, that was a lot of verbiage. Verbiages. All right, so the first thing I'm going to do, if I've got to figure out the number of vehicles, if you were watching 1A, okay, remember, A of t is a rate. That's vehicles per hour. If I just want a quantity, which is vehicles, I integrate. Okay, I integrate. I move backward. So that's what I'm going to have to do. All right, so let me get rid of this. So, but the thing is, where are my bounds? Okay, well, the line forms, let's see, do I have any other color? Oh, that's a nice one. The line forms anytime A of t is bigger than 400. So this is what I'm going to do. I'm going to go to my calculator, and I'm going to see when exactly A of t is bigger than 400. I'm going to go to y equals. And I am going to say A of t, I'm going to put that in y1. 450. I feel like I've typed this in so much. Sine of 0.62x. Okay, that's A of t. Anytime it is above 400, so I'm also going to graph 400, a straight line. All right, I want to add up all those cars. Anytime A of t is above 400. So let's go to my window. Now my window goes from, well, time would start at 0. And I don't know, we'll go 10. I guess we'll do that by ones. Minimum, we'll go to 0. I've got to go to at least 400 on the max, because that's where, I'm starting. Anytime I'm above 400. I don't know, let's go 700. And we'll go by hundreds, so I don't see 700 tick marks. Let's see if this window's good enough here. Good, good. Oh, perfect. All right. Wow. There we go, and there's 400 right there. So if I want, okay, if you follow me here for a second, here's 400. Okay, A of t is in blue. All right? Anytime I'm above that red line 400, that's when the line starts. So I really want to add up all the cars in this area here, starting from this point, because that's when it starts. A of t is bigger than 400 because it's above the line 400 on my graph, to right here, because that's when it stops being above and goes below. So I've got to use my second intersect function to get those x values, or in our case, they're going to represent t. All right, so let me go to second, trace, intersect. And, oh boy, let's go to the mouse, because I got to hold this button down. We'll start to the far left. I'll get close to it and hit enter 3 times. 1, 2, 3. So the left side is 1.469. And I'm going to go out one more place, 1.4694. I'm going to round that, okay, because I'm going to have to use that for a bound in my integration. Let's do the right point of intersection. Second, trace, intersect again. And now I go to the right one and hit enter 3 times. Just get close to it. 1, 2, 3. And that is 3.5977. So this point right here intersects at 3.5977. All right, let's take this and kind of just sketch it. Yeah, sure, why not? All right, here we go. We got that. Let's sketch this. I have this graph here. In blue is A of t. It does something like this and comes down to something like that. Here's 400. A of t. Yep, that's blue. A of t, and it intersects the points. 1 point. And we had that written down as 4, 9. Is that 4, 9 or 4, 6? 4, 6, 9, 3. And this point right here is 3.5977. So if I want all of this, if I want to add up all the cars, I integrate my rates for my bounds, 1.4693 to 3.5977. All right, so here we go. Are we ready? Are we ready? Let's go back to our handy dandy calculator, and we are going to have to integrate this. Oh, let me get this here. Get rid of that. Delete. Get rid of this. Delete. I don't know what that is. Delete it. Second quit. Math 9. And we're going to go from 1.4693 to 3.5977 of, once again, I'm typing this in, actually, aren't I doing, let me get rid of this. I can't just type in A of t, okay, what I wrote here, we got to be careful. It's A of t minus 400. It is the upper function minus the lower function. So I need to write minus 400, then put my dt here, like that. Okay. So let's go here. And let me put the parentheses 450 square root of sine 0.62x, close out the parenthesis for the sine, close out the parenthesis for A of t, minus 400. 100 dt. Wow. That's a lot to type in there. Okay, and that's 71.254. Okay, 71.254. All right, so before I label this, the max of max, the greatest number, I have an interval, which means I also need to check my endpoints between A and 4. All right, now, I'm going to do a little table here and start filling in some values. Okay, my time starts at A and goes to 4. This is the time 3.5977, and I get 71.254. Okay, the output is my n of t function, which is the integration from A to t of A of x minus 400 dx. Now, what happens if I put, well, highlight this blue, A in for t? Look here. If I put an A up here for t, wouldn't that mean my lower bound is A and my upper bound is also A? What happens when the bounds are the same? By rule, the integral will equal 0. So I know it can't be this. So let's put in a 4 for t. Okay, so now I'm going to take this 4 and put that in for t. All right, so let's go here. I'm going to cross this off, and I'm going to put a 4 in here. But what goes in for A? $1 million question. Let's look in the upper right here. I'm putting this star. When did my line of cars first start? Look at the bottom left of the screen. See this graph? Where did this area first start? 1.4693. So my A value is technically 1.4693. So I've got to do this n of t integral where the upper bound is 4 and the lower bound is 1.4693. Now, looking at my graph alone, if I go to 4, okay, let's look at the graph on the left side again. If I go to 4, which is right about, I don't know, here, it's right here, I start losing cars. So it's going to be less. Okay, but let's actually calculate it, and let's do a little cheat mode here. What do I mean by cheat mode? I'm going to copy this, and the only thing that's going to change is my upper bound. Okay, I'm still using the same function, a of x minus 400, but my upper bound is going to be 4. The lower bound will still be the same. And I'm just going to hit enter. 62.338. So this is it. It's right there. Find the greatest number of vehicles in line. You can say 71.254, or you can just say 71. Okay, because again, they're vehicles. That took a lot more time. There was a lot more explaining. There was values that we had to figure out. Then we had to check endpoints. That was a good question. It just gets tough when you have the lower bound as A for a variable which is T. But once you make the connection that your A value is where you start the cars lining up, which again, if I look at my graph, bottom left, the cars start lining up at 1.4693. So that's your A value. Top right, look at that in your interval, which means that's your A value. Bottom right, down there. Once you kind of get that down, they give you the integral. Okay, they give you this. All right, so there's a lot to kind of like piece together before you start getting your numbers. But we nailed it. We're good. Thank God we got to use that calculator, and we're done. So I will see you next time for free response question number 2. Bye-bye.
Don't forget to subscribe and ring that bell.